Welcome to a special episode of Botcast. I'm Mansa, your host, and we have two great guests who bring a wealth of experience in the field of AI. First up is Heiko Hotz, a generative AI global black belt at Google with over 20 years of experience. Great to have you, Heiko.
Thanks for having me.
Also with us is JP, co-founder of SmartBots AI. JP brings valuable insights from innovating in the AI landscape. Welcome, JP.
Hey, hi everyone.
Before we dive in, Heiko, could you briefly share what you are working on lately?
Yes. So, as a generative AI black belt, what I do is I work with customers who want to use generative AI services and products on the Google Cloud platform on GCP. So that could be using the latest Gemini models, training their or fine-tuning their own machine learning models on Vertex AI, using the model garden. We have many different proprietary and open source models on the model garden. So some customers want to deploy those, have a private access to these models. So I help them in all different aspects for them to be successful on our platform when it comes to the generative AI workloads.
Perfect. Thank you. And JP, what excites you most in AI innovation right now?
Generative AI is the most exciting part because it's new, first of all, and then there's so much of scope for innovation. A lot of every day I keep reading in Medium, something or the other new comes up in all these articles. And the excitement levels are at the peak, I would say, this year. So that's keeping me busy as well on working on generative AI.
Perfect. Appreciate the background now. Let's shift our focus to the key topic, which is how to deal with large language model operations. JP will lead us through some technical discussions. JP, take it away.
Thank you, Mansa, for setting the context. Hey, Heiko. So again, I know we have been talking a lot these days about generative AI, and there's a great scope as we see, and a lot of new fields are emerging in this era. And then one of this is the LLM ops that the word has also came up a year back, and I'm so curious to understand more on the details of it. And honestly, my interest is for the enterprise customers we are interacting with. We want to give them guidance on how they can take this concepts that are right now in various forums. How can we take them into the production level? So with that background, I wanted to understand on what exactly is LLM ops all about, and how is it different from the traditional machine learning operations.
Yeah, absolutely. So I think it might be helpful to just give a very quick recap of what traditional MLOps, machine learning operations is. So in traditional MLOps, we combine people, processes, and machine learning into one platform so that it is possible for organizations to train and deploy successfully their machine learning models. And in traditional MLOps, we have this flow where you usually have a particular problem that you want to solve. Let's say you want to forecast your inventory or your demand, and you have certain data, and you train a machine learning model for that specific task to, for example, forecast your demand. Once you train that model, you want to basically use it. You want to put it into production. And once it is in production, you want to monitor it and continuously improve on that. So in traditional MLOps, we have a very specific problem, a very specific data set, and as a result, a very specific machine learning model to solve that problem. Now, how does LLM ops, another term that I've heard recently is foundation model ops or FM ops, how does that differ from traditional MLOps? Well, the difference here is the foundation model itself. The foundation model itself is a much more general model. It is not geared towards solving one particular problem. For example, it's not geared towards, forecasting demand or analyzing the sentiment of a tweet. It can do many, many different things, and it has been trained on a vast amount of data, much more than in traditional machine learning, in traditional MLOps. So The difference comes basically from this new concept of foundation models, large language models being just a special type of foundation model that focuses on text. But with the introduction of these new type of models comes a whole new paradigm, which is then called LLM ops or FMOps. Does that make sense?
So, Heiko, we have seen that the traditional machine learning operations, the starting step is step zero. We don't have any model. By the end of the last step is when the output of that exercise would be a model that gets created. Compare it with the LLM ops, where the step zero is where you have the model ready, and all we are doing is adding the right prompts and fine tuning it to get to the purpose that we have started this exercise with. So, my question to you is: do you see any difference in terms of the level of complexity ML ops compared to what we have in an LLM ops process?
Yes, I would say there are differences. I wouldn't say one is more complex the other, not like in general terms. I would say it's just very different. You now have to consider there's new elements coming into play when you want to run large language models in operations. You already mentioned prompt engineering, but then there is elements of like prompt management, prompt cataloging, testing. One prompt might work on one large language model really well, but it might not work well with another large language model. You need to think about prompt caching. So if a prompt is sent to a large language model from one user and a very similar prompt or similar question is sent by another user, you might want to cache the response from the large language model so you can serve it quicker to the second user who asked the same question. So there's different elements now that come into play when you want to put large language models into production versus the things you need to consider in traditional MLOps.
Sure, and you were also mentioning about LLM ops and are also called as FM ops. Now let us look at what these foundation models are all about, and what is the challenge enterprises would face while selecting the foundation model, and what would be the part of LLM ops or the operations activity around selecting the right foundation model? I understand that there are thousands of them today. We have Hugging Face, we have few of them on Amazon, Google, all the clouds are providing access to these models. So what is your take on them? How are they impacting the operations part of these kind of enterprise implementations?
Absolutely. So the first thing I would encourage each organization to ask themselves is like, do they want to self-host a large language model, maybe an open source large language model like Llama 2? Or do they want to buy basically LLM or foundation model capabilities? And that would be just using an openly accessible API like OpenAI or like Google or like AWS. So there are some organizations I worked with, for example, they were like, we want to use a large language model to summarize our financial reports, but we are just not allowed by InfoSec to use any publicly available API because it always means you need to send your information over the internet to that API, right? If you're leveraging OpenAI's API or Amazon's or GCP's, doesn't matter. You have to send data to them. Whether that data is then saved or not with the provider, you would have to read the terms of services, or maybe you can make a custom agreement with the provider. But the fact is, data will leave your premise. So if that is something that you would not want or you just cannot have, then you would have to self-host a large language model, and that usually means an open source large language model. Another dimension you would want to look at is cost. Cost is very cheap when you start experimenting with large language models. If you go to one of the pay as you go providers, again, that is like proprietary large language models like GPT-4, you pay per token usage. But as you scale up, you could imagine that these costs will become more and more. whereas self-hosting could become cheaper the more users you have, because the more users you have, self-hosting is basically a fixed cost, and the more users you have, the more you can distribute that cost over the number of users, and the cheaper it becomes on a per user basis. So there are different dimensions you would want to look at in order to first decide whether you want to use a proprietary large language model through an API or whether you would like to self-host. So that's your first decision step. And then you would want to look at other factors like context window. Context window is how many tokens can I send to the large language model. I remember around this time last year, the open source models, the most popular ones were like Flan T5, and that had a context window of 512 tokens. That sounds ridiculous today, because now even the standard for open source large language models is 32,000 tokens. But that is something you need to basically look at. What is the context window? Because that will determine how much data you can send to the large language model. Other factors you would want to consider is the size of the model, because that will impact how much it will cost you to host it if you self-host, and it will also determine your latency, which is another factor you would want to look at. How quickly can the LLM or the foundation model give you a response? So there's all these different factors that an organization should be clear about before they start embarking on this generative AI journey.
What about maintenance? So, if you are hosting the model in your environment, you are stuck there, right? Essentially, compare it with a proprietary or an endpoint, an inference endpoint provided by OpenAI, which is continuously evolving. Today, we see OpenAI releases so many versions for different purposes, right? So that is one challenge I see, which the enterprises might have to compromise on if they have to go with a private deployment of a large language model, and the cost as well for maintenance. I'm not talking about the compute cost, but the maintenance cost. What is your take there? Do you think is there a standard operating procedure for maintaining this large foundation models within the VPC of enterprise cloud?
So typically there is only the cost that you're paying is for the compute, as you mentioned. So let's say I want to deploy a Llama 2 13 billion model. I would then choose an instance on a cloud provider. Usually you want to deploy these models in the cloud, unless you have like spare GPUs lying around, which in today's world where the demand for GPUs is very high, I doubt that you have, spare GPUs just lying around. So usually you would want to deploy these in the cloud. You pick an instance in order to deploy the model. What you also would do is then probably use some sort of auto scaling, but that is all done for you. You basically just say, if I have more than 200 requests per second on this model, just, spin up another instance with an identical copy of this model so I can serve these 200 users much faster. So in terms of maintenance, when you go into the cloud, a lot of those operational headaches are taken away from you. You don't have to worry about that. All you need to do is pick the right GPU instance with the appropriate amount of VRAM, so GPU memory, and deploy it there. And deploying is usually very easy nowadays with just a few lines of code, or some cloud providers let you just click through a UI in order to deploy the model. And once it is deployed, you can start serving it. Now, in traditional MLOps fashion, there's still components from MLOps that we need in LLM ops as well. So in traditional MLOps fashion, what you also want to do is some monitoring, in particular around inference parameters or inference metrics like latency and throughput. So basically, am I serving the users fast enough? And you would also want to somehow measure the quality of the output. Now, that is a little bit more difficult since these are generative models and you don't always have like a gold standard you can compare the output to. So you would probably want to implement some sort of feedback mechanism. If you use ChatGPT or Gemini today, you always see at the end of a response from the model a thumbs up or thumbs down that you can provide in order to give feedback to the model response. So that is also something you would want to implement as an organization to collect feedback in order to monitor the model quality. And again, in typical MLOps fashion, at some point, either because a new model came out or because you have collected new data, you would want to retrain or fine tune the model and then deploy it again. And this will be the circle, the typical circle of MLOps.
Sure. I think that's a right comparison to the traditional ML ops and the private deployment of a foundation model. I see some parallels between both of them. And on a continuous basis, we might have to fine tune the foundation model once deployed in your environment. And we need to provide enough pipelines there to ensure that that happens seamlessly. And there's one more interesting observation that I have encountered is the ROI part. Now, the compute is something which, say, one of the departments in an enterprise is incurring. And at an enterprise level, there could be multiple applications of generative AI, and this being a foundation technology, say one of the department, the HR department might want it to build a chatbot, the finance department or say the marketing department might want the same model for summarization or so on and so forth. So what interesting model that I've seen is that now one of the department is owning the compute cost and they are charging per user license within, this is all within the organization for using this service. Because and when I ask more details about why that is the case, then they're saying the reason I get from the enterprise is that the compute the ROI, if they are using it for one particular use case, was not making complete sense, and the compute cost was coming to around 10K per month or something in that range. So, and the ROI to justify 10K was not making sense. So they started a kind of marketplace within the organization and started leveraging this foundation models. So, yeah, that ROI is something which, while the cost might be something the enterprise might consume as a resource infrastructure cost, but justifying for a smaller use cases is something which enterprises are trying different techniques.
Yeah, absolutely. And that is something that where I currently see things a little bit upside down, right? Usually you would want to start with a business use case and then look what kind of technology would you want to leverage in order to solve this particular challenge. Nowadays, I see that generative AI is a little bit overhyped, and a lot of organizations start with the solution or with the technology, which is generative AI, and then looking for, use cases where to apply that. And I think it is important that we go back to, the old way of like identifying challenges and problems that have, if we solve this one challenge, that will have a huge business impact, and then identify the solution. Because generative AI is not always the solution to all the challenges that an organization has.
Right, absolutely. And yeah, so because of the hype, as you rightly said, there is a great amount of interest in finding the right use case. I think this is one stage in the evolution of technology where the solution is ahead, and we are trying to scout for the right problem. And I think that's a good stage also to be. The rate at which technology is evolving is amazing in that fashion. Talking about the people aspect of the LLM ops, so I have been doing traditionally a lot of machine learning operations, and I know the kind of resources I need. I need a data engineer, I need a person who can do ETL, and then data lakes management. Then I have someone who can deal with the data scientist would come in and then try to fine tune the hyperparameters and give the final model out. I know that pipeline, and I'm kind of have a sense of what LLM ops, the people factor is like. But it's still little vague and unclear to me. Can you throw some light on what would be the people factor when we deal with LLM ops?
Yeah, absolutely. So maybe let's start with the prompt engineers. We've alluded to prompt engineering before, right? Basically, what kind of prompts work with what kind of language models. So there needs to be in the organization someone who takes care of the prompt engineering, also the prompt management, or the prompt testers. So not only do we need in an organization someone who can come up with certain prompts in order to prompt the model to do something in particular, like I don't know, extracting key information from an email or summarizing an email or summarizing a financial report versus writing a marketing statement. All these require different prompts, but also these prompts need to be tested against different large language models with different inference parameters. You might have heard of like these inference parameters called temperature or top K, top P, and so on, that also influence how the model will respond. So you will have to combine different prompts with different inference parameters in order to evaluate different models to find out which model is the best for your particular use case. So these are new personas that would come into play when it comes to basically evaluating these large language models. Then you would also still need, or maybe in addition to data engineers and data owners, you would need data labelers or data editors. Because if you fine tune a model, you will need to provide examples to the model. You can do that via prompt engineering. You can basically give a model one or two examples of how the output should look like. But if prompt engineering doesn't get you far enough, then and you want to provide hundreds of examples to the model so it can really learn how you want to, say, for example, extract key information from a document. Let's say you want to extract it in a JSON format. You might want to give your model hundreds of those examples so it gets it really correct most of the time, almost always. Then you would need to fine tune the model. And in order to do that, you need these labeled examples. Basically, here's a document and here is how I want the JSON output of the key information from the document to look like. And you need to create those examples, hundreds of them, with human data labelers or data annotators in order then to train the model. Another one is the fine-tuning aspect. Now, this can be probably done by an ML engineer, but there are certain aspects within fine-tuning that either the ML engineer would need to skill up on, or you basically get someone who is dedicated for fine-tuning foundation models into your organization, because fine-tuning is slightly different from traditional machine learning training, particularly with these new techniques that are coming up in the fine-tuning space. You probably have heard of LoRa and QLoRa, where you basically keep the original model fixed and you're training something called that is an adapter on top of the large language model in order to fine-tune it. And for that, not only would you need someone who is familiar with this specific training technique, but you also need someone then who keeps track of these adapters. How do we store these adapters? Can we swap them out? Can we, layer them on top of each other? So that is also a new kind of persona that is coming into play. And lastly, you have the AI engineer. That is basically a solutions architect who is very familiar in how to leverage these new capabilities of the foundation models. So again, that could be someone existing in your organization who just learns how to include foundation models in a particular application, or it could be someone new in the organization. But these are the kind of key personas that I see coming into play when it comes to foundation model operations.
Sure. So you were mentioning about the similarity or the differences between fine tuning and the model training. And traditionally, in the model training part, the role of a data engineer would be little on the higher side. Can the data engineer morph themselves into a fine tuner by handling? Because I see the size of the data is also similar when you are dealing with fine tuning and training. So is that a good way to look at path where we have our traditional data engineers who can also morph into the fine tuning part?
Yeah, absolutely. So I think I mentioned that earlier. There are new personas when you look at LLM ops versus traditional ML ops, but that doesn't mean you have to have new people hiring into your organization. Lots of these personas are very close to the original personas of a traditional ML ops lifecycle. So it is absolutely possible that you basically upskill your existing data engineers to become data labelers for foundation model ops, FM ops. Yes.
Sure. And also I see that the role of a solution architect more from an application standpoint is kind of increasing when we are dealing with the LLM ops. Like mostly I see prompt engineering is close to solution architect's role than a data engineer. So, and because now we are not just building a model, we are also solving a business problem by building an application, be it a email summarization tool or content generation tool. So I see that the role of the solution architect is also has come into the LLM ops space as well.
Yes, absolutely. So basically, a traditional solution architect in the AI ML space, they already know how to deal with machine learning models. And so for them, it is not too different if they're now dealing with foundation models. The only difference might be the type of data and how that is processed in the foundation model. Taking a step back, large language models have been predominant the topic in 2023. I believe in 2024, multi-models will become increasingly more popular. So by multimodal, I mean models that can process not only text, but images, video, and audio, and basically unifying all those inputs and presenting them to the model that can process all these different kinds of inputs in one go is something that a solutions architect needs to be aware of, but probably very easy for them to upskill in that particular area.
So now that you're talking about the multimodal models, which I believe are generally large in size in terms of the number of parameters, compute cost, and in all dimensions. So, what would be your take on the smaller size models? How will enterprises take them? I see a lot of benefit in the smaller models as well, based on the use case. Do you see that it would be a combination of all these models existing in an enterprise ecosystem, or it would be dominated by the larger models? How do you see them?
I think it would be a combination of small and large models, and that's because exactly what you mentioned earlier is one organization. Within one organization, there are different teams with different use cases, and that means they have different needs. And some of the use cases can be solved easily with small large language models. I love that term, by the way, small large language model. It's like almost like a contradiction in itself. Yeah, so let's say you want to do just summarization of financial reports. There's nothing multimodal. All there is text, and I want that text to be summarized. I think that can be easily done by a 7 billion or 13 billion model these days, and there is no need at all to use one of the really large multimodal models, in particular because by increasing the size of these models and the complexity in these models, you will increase cost and you will increase latency. And that just means you are using basically a Ferrari to go down the street and buy, some bread from the bakery, which is just overkill. So I think every organization will look at the costs and the latency of these models, not only the quality, and be like, you know what? For this particular task, a 7 billion model is more than good enough for us, because we don't need it to write poems in the style of Shakespeare. All we need it to do is write summarizations for our financial reports. That's the only thing it needs to do. It doesn't have to, write poems or digest images or videos. So I see a future where organizations will use different large language models for different tasks.
Right, right. So, and that again, I'm circling back into the earlier topic on deploying a private model inside the enterprise ecosystem. And the topic that I'm interested in is in the data security. I keep hearing this multiple times. People, especially enterprises, are skeptical about exposing the data to large language models. And so, when so the straightaway solution for that is to deploy and preferably the smallest, best fitting model into your environment and then start using it. So, and then maybe you can deploy more than one, have them maintain them, and we have discussed about all the challenges. Tell me one thing about the security aspects, assuming that the provider has clearly indicated in their license agreement that they're not going to use the data for training the model. What would be the suggestion that you would give to enterprises? Because there might be use cases where you really need that size of model and it is not practical to deploy it in your VPC. In that case, what do you suggest to enterprises? Are there any other ways that enterprises can deal with this situation to tackle the data security aspects?
So, first of all, I think I would challenge the statement of like the model is too large, we can't deploy it in our VPC anymore. So back in my times at AWS, we were working with customers who wanted to deploy 180 billion models in their VPC. And that really can be done with like the largest instances and with a technique called model sharding. Basically, you don't put one model, the whole model into one GPU, but you're going to have an instance with like 8 A100 GPUs on it. That gives you 640 gigabytes of VRAM. And that is more than enough to host even the largest large language models out there. So that is still possible. And I would always recommend to a customer to first, but like if security and data privacy is of the highest concern, I would always urge a customer to first look into self-hosting. And if self-hosting is not an option, then, well, it depends on, the cloud providers. And I'm not legal expert in terms of like what their terms of services are. But my understanding is that the leading cloud providers offer you a setup where they host the large language model for you, and they can guarantee via technical implementation, not only guarantee on legal terms, but specifically and how they implement this whole pipeline technically, they can guarantee to you that neither the cloud provider nor the model provider, which can be two different entities, can access your data. So to give you an example, on Amazon Bedrock, there are ways to deploy a model that is specific to you where neither Amazon nor let's say you are using Anthropic's Claude V2 model on Amazon Bedrock. So neither Amazon nor Anthropic will be able to access your data that you are using to either fine tune the model or the data that you send to the model for inference.
That brings to the last topic of the conversation today. We have covered the people aspect, we have covered what are foundation models, we have covered a lot of topics around foundation models. And now the last topic is on the security and the future trends of FM ops and LLM ops. So on the security aspects, the one more point I wanted to make is about the way the data can be, if there is a personally identifiable information. If you implement a layer which obfuscates or then masks this data and then sends to LLM, that maybe the security aspects can then be handled. Or do you see that enterprises are okay with this kind of a solution where you add a layer of filtration before sending to an LLM?
Yeah, that is oftentimes even a requirement for many of the organizations. So in that scenario, you would have basically a system. So basically you're leveraging more than just, the large language model or the foundation model in the backend, but you would have another model in front of it, exactly as you say, that is specialized on filtering out PII data, personal identifiable information, before sending it to the large language model. So that is actually a requirement for some organizations, especially, for example, in the healthcare and life sciences space.
Right. And banking and finance is also one area where I see PCI, DSS, the card information or person information. If we are able to filter out and send to a large language model, maybe that I see could be one potential solution, at least to mitigate few of the requirement security threats. And the last question for today is on the future trends of the large language model operations, foundation model operations, the people aspect of it. How do you see this year is going to be? And any best practices that you suggest for the enterprises, especially when they are trying to they're looking at investing their capital in this direction. So, what do you suggest to the enterprises for 2024?
Yes. So from what I've seen in the past 2 months, what is going to be really big in 2024 is what is called retrieval augmented generation, or RAG. And that will introduce a new layer of complexity into LLM ops or FM ops. Basically, what you do in retrieval augmented generation, or RAG, is you retrieve additional information before you send a user query to the large language model in order to answer it. One of the canonical examples in this case is who won the football match last night. The large language model will not be able to answer that question, but what you can do is you can first retrieve information, maybe from the internet or from an API, from a sports ticker, information on that particular query before sending the query together with that retrieved additional information to the large language model, and then sending the query to the large language model. And now the large language model is able to answer and reply to the user. Now, this kind of systems, these RAG systems, will become increasingly more popular because it allows organizations to basically use large language models as a search engine within their own documents. So imagine you are an organization that has tons and tons of unstructured text documents on the Microsoft SharePoint, for example, and they're like, we have no idea. Where, like, there's a document somewhere that tells us what is the opening hours of our store on Main Street, but I don't know in which folder to look for. This is something that large language models are absolutely great at, is like passing this unstructured information. So basically, if you build up a system where a user query comes in, you retrieve the relevant documents from wherever you have all your text documents lying around in your organization, and give all of that into the large language model. The large language model will be able to pass your query and the additional information and give you back a answer to your query. And we could spend another hour just talking about the complexities that will be introduced by this new kind of solution. There's a new aspects of operations that will come into play. But in short, this is something that I think most organizations will focus on in 2024.
Great. Heiko, in that context, I have one last question, which is again, I'm trying to combine the RAG and the private deployments. Do you see any case where the entire RAG-based solution is deployed inside a VPC, or do you use that for enterprises?
Yeah, absolutely. That is something I'm working currently with customers already on. Is like having everything deployed in their VPC, because the nice thing about rack solutions is it again doesn't require the most biggest, newest large language model. If you have a very focused, narrow large language model, maybe fine tuned even, 13 billion is more than enough. You might have other large language models in your RAG system in order to improve the accuracy. So, for example, if you think about retrieving information from text documents, what you could do is use a large language model in order to rephrase the query from the user in many different ways, retrieve information based on these different variations of the user query, combine all those documents, again, maybe together with a large language model, before sending all this retrieved information to yet another large language model. But again, all these different versions of large language models don't have to be huge, could even be the same one. So yes, all of those should be able to fit into your VPC easily.
Thank you, Heiko. Really, these conversations are very insightful. I'm sure the enterprise audiences who are listening this would get a lot of value from all the points that you have mentioned. Thank you very much.
Thanks for having me. Yeah, absolutely pleasure.
Well, that wraps up our exploration into LLM ops. Heiko, I would like to ask you, are there any one or two main takeaways do you want the audience remembering about large language models?
Yes. So basically, what I want the audience to take away first is start experimenting with large language models. The nice thing about it is you can start experimenting very easily with these APIs, right? Only when you then go into production, you might want to think about a different setting, but start experimenting because you can layer these different complexities on top of each other. So you can start with a very easy use case, just check out whether the technology works for you, and then start layering on top of that.
Perfect. Excellent LLM summary, I would say, from entire conversation. But any final thoughts to close out, JP?
Yeah, so this is the most exciting space for me for last year and this year as well. I'm really keen to speak to more experts in this domain, understand, learn, and then help enterprises sail through this interesting evolution and be part of it and contribute as much as possible.
Thank you, Heiko. Thank you, JP, for joining us today. It's been wonderful having you on Botcast. Appreciate you both highlighting key learnings on large language models, and the discussion has been invaluable for anyone looking to leverage LLMs. Now, to our viewers, stay tuned as we unpack more aspects of LLMs and other AI advances. Join us next time as we continue decoding the future on Botcast. Stay curious, stay informed.